Sundar holds on from Malawi Institute of Technology, MNIT Jaipur, and has specialized in the areas such as mathematical modeling, epidemiology, biomathematics, fractional calculus, integral transformation, and special functions. His research contributions have significantly advanced mathematical applications in real-world problems, particularly in diseases, modeling, epidemiology, and integral equations. With an impressive portfolio of numerous research publications in high-impact journals, Dr. Shyam Sundar has made notable contributions to applied mathematics, tackling challenges in healthcare, epidemiology, and fractional calculus. He has also presented his researches at various national and international conferences and has been session chair and invited speakers at esteemed academic gatherings. His expertise extend beyond academia as he is an active reviewer for prestigious scientific journals and a member of several international mathematical societies. His dedication to mathematical science has been recognized with the accolades such as the Young Scholar Award and the multiple prestigious research fellowships, including NET JRF in mathematics. In addition to his academic and research achievements, Dr. Shyam Sundar is deeply committed to mentoring students, guiding researchers, and foresting innovations in mathematical science. This work exemplifies a blend of theoretical excellence and practical applications, making significant contribution to both academic knowledge and real-world problem solving. Ladies and gentlemen, please join me in extending a warm welcome to our distinguished chief guest, Dr. Shyam Sundar sir.
Yeah,
Thank you.
Yes.
Thank you, Vaishnavi, for your lucid introduction. Now I'm delighted to call upon rising star of today's session, Dr. Sham sir, to deliver keynote address.
Yeah, thank you. You have wonderful introduction. Very good evening, one of all. Yes, and also thank you for the organizing team for inviting me. It's my pleasure for today talking for mathematical modeling for bridging theory and real world applications. Yes. Okay. Yeah, my screen is visible.
Sir, it's visible, sir.
Okay, ma'am. Okay. Okay. Today talk is based on the mathematical modeling, like two applications of the real world applications. Then we start to mathematical modeling. Why to start the mathematical modeling before to how to develop the mathematical modeling and which areas we work the mathematical modeling and how to calculate the results and how to imply it in human society mathematical results and how to survival in this mathematical world and this the planet. Okay, then we start this talk. Then these are the some outlines for the this talk, the motivations and the mathematical modeling, the basic examples, and then after the finally conclusions. Then we start the mathematics from the beautiful thoughts, the Sri Nivasan Ramanujan said, the beautiful quote, an equation for me has no meaning unless it expresses a thought of God. That's when the thoughts of God is also the main in the equations. Then in the word, the thoughts of God, this is beautiful the nature, beautiful society, beautiful planet. Then the thought of God is the beautiful nature and the society. The beautiful nature and the society, we focused on the 5 fundamental elements. We are being all our survival living in the around of in these 5 fundamental elements. Then the survival of all living beings to depends on the upon in the Hindi word is Panch Tattva, and the 5 elements, otherwise the 5 components. The first is the air. The most important part of living for is this planet. Then we need air, and second is the water, third is the earth, land and resource, Fourth is fire, energy, and the fifth is space and total environment in the units. In these five fundamentals, the conversations and the improvement of these five fundamentals elements more important for the survival in the life in this planet. Then our research will focus on the conservation of improvement of these five assets using the modern science and technology. Then with these five fundamentals is elements converting then more than different parts. Then the suppose water is converts river, sea, and the sea waters. Earth is land and resource and mountain, hills, these types. Fire is energy. Energy is the next meaning. The green energy now is the current scenario is very useful. Then we start this work, then the linking of nature with the society, then the understanding this connection between the nature and the society is the key solving problem, is key solving challenging in the general current scenario in world. How to reduce the population, how to control population growth, how to control the epidemic disease, like to all are aware the COVID-19, and is currently we see in the last before 2 3 months Los Angeles wildfire. That's the all are the effect of nature society. And also we know the Israel and the Philistine conflict and the Rus and the Ukraine conflict. These are the ultimately all things are the effect on the nature and society. Then we solve these global challenging, and the one of part these solutions we help of the science and technology through the mathematic modeling and the etc. another process. Then the we in nature and we got it gifted on the these are the beautiful nature we need all everyone, the mountain and hills for the survival in the life, and the secondary the rivers and lake and the seas, this the forest and groundlands also need cool to for the survival in the nature, and the landscape and underground resource, the oil and the minerals and the many other elements for the for needful to human and the living the in the survival in this world. And the sea and its resource, and the monsoon, sunshine, and the all living beings that in about the fundamental elements now to mountain, river, forest, etc. And the social needs to we in the current scenario we need population and control, food security and agriculture, and fresh air and water. Everyone they need to fresh water and the air, and housing, healthcare, education, and etc. That in 1980, the Mrs. the Prime Minister Indira Gandhi also in the election campaign in court, everyone we need goes to housing, cloth, and food. In the also a create a movie Roti Makan Kapda. Three are the three fundamental requirement for the woman in 1980 is the caught by the Prime Minister Indira Gandhi. But in now in current scenario is three, not three, is now is the five. Then the first is the food, second is the housing, and third is healthcare, fourth is education, and the fifth is cloth. In 1980 is okay, but there is the in the population in 1980 surrounding in India, I think the 70 crores. Now is the ultimately double. Then also the needs of also is the maximize. Then the bridging environment and societal challenge, the balance of natural resource conservations and the human development is critical sustainable progress. This the balance is more important for the survival in the next future generations. Then we factor effective to nature, the like to population growth. In India, last 50 years, the population is ultimately double. Now is one around 150 crores, and 1975 around in the 70 crores. Then there is very very challenging problems in the current scenario is population growth, how to control. And second is epidemic attacks. We are all aware in COVID-19 in 2020 is starting. Then the epidemics before the COVID-19 is the swine flu and cholera and Zika virus. And currently see also in the Pakistan and China is monkeypox again. And the technology revolutions. The current scenario is technology is very fastly growing, but the e-waste also is an effect on nature, like to smartphone, tablet, uh, laptop, and smartwatch. All are things that is effect on the nature. E-waste. They also control the e-wastage and the urbanizations. Then the peoples are the migrate to villages to city and goes to then the villages are empty and the city and civilizations is also increased. Then also impact on the nature. And the next is the industrial development. All aware the industrial development is the effect of nature, and there is the Paris Climate Agreement in 2015. They also focus on industrial development and also target to carbon emissions and also temperature reduce in the global temperature reduce 2 degrees Celsius. It also is a effect on nature and the infrastructure expansions and making the airports and the roads and these roads and the making then the ultimately the forest also affect the hills also cutting and the tree also cutting and the overseas of nature resource the cutting the mountains and the cutting the trees is etc. Also the non-conservations of nature like to the minerals and the oils is non-conservations of nature, then the is safe, then is future society and the future generation is good. Then the key environmental and societal challenging, the first is deflections of nature resource, then the, like to the cutting the hills and the trees and deforestation and the conservation management and the effects of population and industrializations on resource augmentations of resource using the new technology like to in the current scenario everyone take the smartwatch smartphone and the laptop before these are the also produce the also some carbon and some x-ray like kiran and different types to like spectrum. These are the effect on the population and the population diffusion on rural migrations goes to the city, then the villages are empty and the civilization increase and the coexistence of species. The currently in the last year, the tigers brought from the South Africa for the maintaining the coexistence of the in the forest. Then the tiger also the part of the coexistence city and the like to lion and the human and the bird. That's all are things that for the ecosystems is the important for the in current environment challenging and the biodiversity and sustainable development. Then sustainable development is the 17 goals. If we goes to next slide and spread of disease. We all aware the malaria, COVID-19 is all are aware and tuberculosis, AIDS, HIV. These are all spread of the disease controlled and their control and vaccinations campaign. They are important and challenging environmental and ecological effects on vector-borne disease like to monkeypox and dengue disease all are known as vector-borne disease. In this disease, like to one is the human and another is the non-human. Like to in the monkeypox through the monkey and in the mosquito through the dengue. The spread of disease with multiple pathogens, the infections like to hepatitis B and the schistosomiasis disease and the bioterrorism and the chemical terrorism also the effect on the society. These are the major challenging in the current scenario. Then the why we research matter, these types of research, how to control, then the scientific research must be focused on the long-term sustainability and the processing research for the future generations. Then the Paris Climate Agreement that develop the 17 goals of the sustainable development. Then the first is the no poverty, second is zero hungry, and these types of 17 goals that decided By the 16, most of the first and the second and the fourth, these are most important. Then after all are the 17 goals are important. Then 17 the partnership for the goals. Then the 16 is goal and 17 is the all are the mixing. Then the develop in the 17 goal. And the all countries is the agreement, the Paris Climate Agreement is signed. And then recently Donald Trump are the removed, but no idea. And the reduced temperature and global and the green energy. These are the major things of the sustainable development. And the then after the sustainable development, we increase these types and they control these things. Then the how to purpose of the our research. Then to understand the natural phenomena related to various episodes so mentioned above, like to hills, mountain resource, water resource, air, food security, agriculture, all are the natural phenomena related to how to control these types. This research is focused on the direct and toward survival of living being and the welfare society. Then the how to control these things with the help of science, technology, engineering, and environment science. How to control these things and we happily enjoy full life to survival in the society. The role of the present generation is not just to use resource for itself, but also preserve them to for the future generations. Like to next generation is wetted, then it definitely for the is preserved for the future generation is for good. Then all things are there is control the resource and the improvement and the conservations for the these resource. Then the objects of this study, commitment to advancing high quality interdisciplinary research. The currently all sustainable development are the interdisciplinary. Then the science, the all sciences, the bioscience, chemical science, physical science, all sciences. Engineering, all engineering, like to chemical and the civil life and electrical, electricity, and the all are. And technology, the general the current generation is the machine learning, artificial intelligence are the most impactful technology and environmental. Then the commitment of the advancing the high quality interdisciplinary research, then the bridging science, engineering, technology, and the environment to address real world challenging through the innovations on the solutions. Integrating fundamental scientific principles like to apply to science formulas and the mathematical formulas, any other the statisticals. These are the cutting edge in our engineering technologies, emerging technology advance like to machine learning and AI technologies and the sustainable environmental practice to drive the impactful research for the societal progress. Then the major objects that control these things. Then the final thought, the mathematics is the language of nature and science is the key to unlocking its secrets. Then they are interlinked, then they're called interdisciplinary. And according to Galileo Galilei, the famous quotes, mathematics is the language in which God has written the universe. Then we start to modeling this today topic. Then what is the modeling? Then the simple description of a system or progress for calculating or predicting what might happen. That is known as the modeling. In next we goes to then the mathematical modeling are the compared to modeling. Firstly, we simple descriptions how to calculate and the predictions and the assumptions take the and how to results and the calculate these things. Then known as modeling. The modeling is the process of creating a representations of a system and the object or idea order to investigate, understand, and analyze its behavior. How to that's in the how to collect the observations and then after implementations and implies and interpretations and the conclusion. And there's analyze. The why is used to mathematical modeling the generations of the physical and conceptual and the mathematical representations of a real world phenomena that too is the difficult to observe directly, like to the COVID-19, how to COVID-19 is spread and how to decrease and how to control and the vaccination campaign, how used to these things. Then all our things are the use the modeling and apply the mathematical modeling. Easily we solve these problems. then easily in the 150 crores in the India population, then the directly are not possible. Then the models are used to explain and to predict the behavior of real objects or systems are used to in variety of scientific disciplines ranging from the physics to chemistry, chemistry to ecology, ecology to earth science, or all the interdiscipline like to physics also with the mathematics, physics also chemistry, chemistry plus physics also mathematics, ecology, earth science, and the environment science, or all the interlinked, then known as interdisciplinary. Then the types of modeling, then the many types of modeling, the mathematical modeling, the one of the type, and the statistical modeling, physical modeling, computer modeling, 3D modeling, conceptual modeling, process modeling, and the behavioral modeling. The statistical modeling, the statics process, they like to stochastic and probabilistic modeling, and the physical modeling, they like to environment science and the physical chemistry, and the computer modeling, the computer virus modeling, and the ethical, unethical modeling, these types, and these are or modeling, also analytic modeling to like to directly solve these things. Then the mathematical modeling, what is the mathematical modeling? A mathematical modeling is a powerful tool. That's the mathematical modeling from the modeling. Modeling that's in the we define the real world problem and convert in the system. There is known as modeling. This process is known as modeling. And this system is the in equations form, in the mathematical form, there is known as mathematical model. That's the mathematical model is the powerful tool for understanding natural and artificial systems using mathematical concepts, formulas, equations to analyze real world problems. The mathematical modeling is enable predictions, optimizations, simulations across science like to engineering, technology, environment to solve these complex problems. Then why is the maths model? According to Balam, is in this paper is mentioned this statement in 2011. Modeling is the important for the researchers because mathematical models or modeling are everywhere around us. Often is the connections with the powerful technological tools like to MATLAB, Mathematica, these solution tools, and preparing students for responsible citizenship and for participants in societal developments requires modeling competency. Then the systematic representations of mathematical modeling, then the visualizations and the identifications of the problem, understanding the problem and the interpretation of the problem, and then finally the conclusion of the problem. Then we start here the real world problem, the approximation, then apply the something and this real world problem convert in mathematical problem, then the real world models. Then these types to then apply the mathematical expressions, mathematical formulas, equations. We solve like to any numerical solution, analytical solutions, any type solutions, and we convert the mathematical model. And these solutions then find the conclusion and the comparison to the real world problem. Then we goes to simplest example of the mathematical problem. The first here, the first in the column, the real world problem, and the mathematical problem we convert, and then after solution and the conclusion. Then we take a simplest example of the real world problem. Like to distribute 100 rupees between two people such that one receive more than 20 rupees to others. These are the real world problem. Basically, the basic example all are aware, but how to they employ the mathematical modeling. Then the let's suppose two x and y, two are people, otherwise two objects, like to among these the divided this amount 100 rupees. Then suppose first is the x plus y, that is 100, and total amount is 100, then divided by two people, then first is the x and the second is y. And the second statement, one receive more than 20 rupees to other. That's the suppose y receive more than 20 rupees to comparison to x. Then easily we solve this problem, all aware. Then x is equal to 40 and y is equal to 60. This is known as the mathematical solutions. This is known as mathematical model. This is real that are real world problems. This they convert in the symbolic form. In the mathematical form, there is known as mathematical model, and this finally is solutions. Then is known as mathematical solutions, and hence that output and interpretations then is known as conclusion. Hence, will we get 40 rupees and another we'll get is the 60 rupees. Then the mathematical modeling process, how to calculate these things. Then the first is the problem formulations. Then that means the problem formulation. This is known as problem formulations. How to calculate the variable x, how to define the variable y, two variables. This is known as this part known as problem formulation. Then identify the real world problem. Firstly, we identify the real world problem. Then imply the mathematical formulations like to define the variables and the parameters, how to make the simple assumptions like to take sometimes less than, greater than, these type of assumptions, more than. Then they had the more than. These are the more than 20 is known as the assumptions. Okay, then we goes to next mathematical model development. Then the translate this problem into mathematical equations, and the inequalities is known as mathematical development. This is second is the process is known as this part known as mathematical development. There's model development. Third is model solutions. Solve the mathematical equations or inequalities using the analytical numerical methods. Any softwares like to MATLAB, Mathematica, Maple, Python. Then this solution we process, and lastly the model validations. The compare the models for the prediction of real world data, and the refine the model is necessary. If results are not good, then the refine again, and the out lastly we got the good results. The model interpretation analysis. The interpret the results of the model and draw the conclusion, make the predictions. These are the mathematical modeling process, is major process. And the types of mathematical models. The deterministic model, first is the deterministic model. The outputs it determined solely by the inputs, like to linear regressions, differential equations, and fractional differential equations to imply the deterministic models, and they easily solve these things like to analytical and the numerical methods. And second is the stochastic models. These are the is the also known as compartment modeling. In this model is develop the comparts, then the compartment class model, and stochastic models involving the randomness and the uncertainty. Then we solve these problems. The probabilistic model, statistical models. These are used for stochastic model. And the third is static model, analyze the system at a specific point in a time. Then the linear programming and optimization problems. Then the transportation problems, and the supply demand problems are the known as static models. The dynamic model analyze the system over time. Then the differential equations we use to differential equations and the difference equations. Then we easily analyze the dynamical models. The applications of mathematical modeling in all our areas. The first is the engineering, the structural analysis, fluid dynamics, control system, and the turbine system. All are applications in the engineering parts use the mathematical modeling. And the physics, classical physics, astrophysics, quantum mechanics, electromagnetism also use the mathematical modeling. In the astrophysics, how to calculate the distance between two stars, between two suns and stars. All are things that depends on the modeling. In the biology, the population dynamics and epidemiology and genetic. Epidemiology, all are aware. The epidemic text like to COVID-19, these are things, all the biological mathematical modeling. And economics, supply and demand, economic growth, financial modeling, also the part of mathematical modeling. The environmental science uses of mathematical modeling, the climate change, population control, resource management. The climate change, that today is also World Meteorological Day, is devoted for the weather, climate, and water resource, how to control. Then the also the beautiful for the today and the World Meteorological Day is 23 March. Then how the mathematical modeling also used to in the weather, climate modeling, and the water resource things. The biotechnology, genetic engineering, and drug development, and bioinformation, synthetic biology, and tissues. We just now goes to next slide. Then with some examples like to take the biology and the environment science, the biotechnology. And the first we go Okay, and the limitations of the mathematical modeling. The first is the model assumptions. How to assumption the model, how to then after check the model. Sometimes we assumption the model, but then after results are not good. Then they refine the model. Also the technique solutions we check. Then there is the also limitations of the modeling. And second is the data quality. The quality of the input data affects the modelability. Sometimes the data is not available. Like to we need different type data, but is secondary data is also available, but primary data is sometimes we collect the in the sampling, then is finding the error that is also effect on the results of the questionnaire. The computational complexity, the complex model may be required the significant computational resource. Like to sometimes the model is very complicated. Then how to solve this model is not easily for the paper pencil solutions. Then we use to computational tools like to MATLAB Mathematica. Then this computational simplicity also available in the modeling. And the model validations, it can be difficult to validate the model, especially for the complex system. Is big models, then there is also the validation is also big problem. Then we goes to simple some basic mathematical modeling examples. Mathematical modeling is a powerful tool to help to understand the predict the real world problems. All we see the previous slides. Here is some basic examples to mathematical modeling. And the first is the spread of disease. Then the firstly the real world problem. How to is a human generally is non-mathematical student, and then the how to real world problem. The first question, how does a disease spread through a population? Then how to control this disease? Then the first is the mathematical model. Then we develop a model that we known as the compartment model to track the susceptible and the infected and require individuals populations over a time. And the first simplest and the first model in develop for the spread of disease in the SIR model, susceptible infected record model, is developed by Kermack and McKendrick in 1927. This model, how to behavior or predict a behavior, very similar to observation complex epidemics. In this model, some assumption take. Then the first assumption is that no birth or no death rates in the population during the disease outbreak. And second is the total population size remains constant. Third is the infected individual immediately become infected infections. That's the if infected populations are the recovered, that should do not rejoin in the susceptible class. And the third is the transmission rate beta, and the recovery rate remain constant all the time. Then the components of these equations. Then the components first is the susceptible for the S, generally is denoted by S, infected by denoted by R, I, and recovered population denoted by R. These are three components, and the first is susceptible, second is infected, and third is the recovered populations. And also some modeling in the recover and the remove. But in the Canmeric entry, also recovered only now. This is the structure of this dimeritical plot. So flow chart. And the S is the susceptible populations, and beta is the transmission rate, I is the infected populations, and gamma is the recovery rate, and the R is the represent recovered populations. These are three compartment model, and these are the three components as I R. Then we convert in the mathematical equations. The first is the uh, rate of change in susceptible propulsion with respect to time t, then they denoted by ds upon dt, like to is equal to minus beta si, and second is di upon dt is equal to beta si minus gamma I, and third is the recovered population. Then the change on the recovered population with respect to time is equal to gamma I. Then the susceptible equations, the number of susceptible individuals decrease if they come to into contact with the infected populations. Then ultimately the susceptible population are decreased and the infected population are increased because the susceptible population goes to a class on I. Then the susceptible decrease and the infections are increased. The infected population increase, but sometime after the infected population also decrease because the infected population also recover and remove. The number of infection, the second equations represent for the change in the infection class with respect to time t. The number of infected individual populations increase in the first half, and the because the susceptible individuals are joining the I class, and then after the infected populations are decreased because are recover with the gamma rate, and last is recover populations. The number of record individuals increase as infected individual also recover at rate gamma. Then the graphical representation of the SIR model. Then the here is the firstly start the yellow line is show that the susceptible population. Then the starting the initial the susceptible population is suppose here is 100 like 200. Then there is starting point is 100. Then after is goes to beta rate is joining the infected rate class. Then infection is starting is 0 initially, but susceptible population is joining the infected class. The infected class are increased and the susceptible population are decreased. And after some time the infected population also some people are recovered, then also recovery is started, and sometimes after the susceptible population also totally decrease and infection populations also decrease, and the green line show for the recovered population also increase. These types the behavior of disease is this important part of the COVID-19, and many models are developed in COVID-19 like to SIER, SEIR, SIRS, many types models developed for the study COVID-19. The SIR model is suitable for the infection disease where individual transmissions through the three compartments, the susceptible, infected, and recover class. Then this model implies many disease like to smallpox, chickenpox, influenza virus, Ebola virus, Zika, COVID-19, and chickenpox, polio, hepatitis A virus, dengue fever, plague, typhoid, many diseases, and then apply these models. Also, this model apply in the computer science. Also, then the apply the in the corruptions and another sciences. And the key feature of disease for the assay applicability, the recall leads to immunity, the temporary lifelong, and the disease does not have the significant latent period, and the reinfection is rare during the immunity period. Then the development of this model known as IRS, as EIRS, the for disease for immunity wanes and reinfections occurs or latency exists. Then extended models such as SIRS model. Then the susceptible, infected, and recovered population also lose the immunity. Then again join the susceptible class. Then sometimes the okay we recover the disease, but then after 1 month, 2 months also we see the symptoms. Then also we join the susceptible class. And like to as EIR model, and susceptible, exposed, infected, and recover. Like to sometimes be susceptible, but then after we check the test as test the disease test, then sometimes are positive, sometimes are negative. If are the negative, then we exposed, and we that means remove. In this stage we remove, and is negative positive, then we goes to infected and recover population, recover individuals. Also we some updated in this model. Then we see this my article, and this is a deterministic model for the susceptible, vaccinated, and exposed, infected, and the recover population. Then it knows known as SVEIR model. Then the next with the goes to population growth model. The different type, first is the infection model, second is the population growth model. Then how does a population of a species change over time? And mathematical model, this is statement we convert in the mathematical process. Then we simple differential equation with the model population growth. dp upon dt is equal to rp. P is the population at time t, and r is the growth rate. We calculate the sum time period it take. Suppose 1 year population is counting and the second population is counting, they will take easily and they convert this. And t is the time. Then this model is the can we predict increase, decline, and the stabilization based on the environmental condition and the constraints. Here are the main types of the population growth models. Currently, the Indian population its growth rate is very high. Then the solve this differential equation. The solve this differential equation is very easily. Then we goes to in the exponential form. Then the exponential growth model assumes the population grow at a constant rate without any resource constraint. And the P naught is the initial value, at T naught at the time T, and E is the Euler constant. The key feature growth is unrestricted and accelerate exponentially. That's E is known as exponentially function, and common is environmental and with ultimately resource. Then the next model is the biomathematics. The first is infection, second is the population growth, third is biomathematics. That's the drug diffusion. The drug diffusion is major part in the human life. How to take the drug diffusion in the body, like two three types. First is the powder. The drug is also powder form. Drug is also capsule form. Also in the tablet form. We take oral, that's in the mouth. Sometimes we take the veins, and sometimes the in muscles. Then for example, paracetamol and any disease like to for uh, the mouth oral delivery, that's from the mouth, the tablets. And secondary, then the glucose, the drip in the human, then they like to veins directly the glucose in, then the inclusion via the veins. And third is the like to vaccinations. The vaccinations take in the muscles, not in blood, not in oral, it directly muscles. And the COVID-19, everyone take the vaccination, they are directly on the muscles. And like to tetanus vaccination and the other vaccinations indirectly goes to in the muscles. Then the drug diffusion is major part. Then the three models we take. The first is the oral delivery, goes to stomach. That's directly the capsule and the powder form, or take the oral. This the two compartment model. The U is the stomach, GI tract, gastrointestinal system, and V is the denoted blood. Then we take the oral delivery. Then we take a capsule, a tablet. Then we easily understanding. The firstly goes to tablet in stomach, and then after a work and the goes to in the veins in the body parts, and goes to in blood. And lastly, we in mentions by the body, the liver and the things, other things. This model we convert in mathematically very easily and focus on two compartments. First is the U and second is V. Then the U represent a GI tract or stomach, V represent the bloodstream. Then the mathematical representation of this model, du upon dt is equal to minus a u. And second equation for the second compart, dv upon dt is equal to a u minus ev. Very simple. U is represent for concentration of the GI tract in the drug, and concentration of the drug in the bloodstream. And A and E are the represent for the transmission rates. And B is the initial drug dose. We take 500 mg, 200 mg, 100 mg like to this. And this solve this model, easily we predict the behavior of the drug diffusion in the human body via oral delivery. And second model, we goes to the like to in the muscles, directly in the muscles, not in veins, not in the oral delivery, is the drug infusion directly in the muscles. Or COVID-19 vaccinations directly in goes to muscles. And tetanus also these types of vaccinations. Then the is two also two compartment model. Then we drug infusion via the injection through the muscles. Then the first is the goes to in blood. After muscles goes to blood, and after it goes to tissues, and tissues and the blood are interlinked, and also elimination via the blood, and then after liver flow. Then the drug acts therapeutically blood in this system, and the second tissues they use the drug act. Then this model also converting two equations. The first equation is known as the dx upon dt, and second is equation dy upon dt. Then the x is the blood and y is represent of tissue. Then two compartments, blood stream and the tissue. And the x represent the concentration of the drug in the blood, y in the concentration of the drug in the tissue. And B, C, E are the transmission rates. So, and B naught also same as the initial drug dose. They solve these equations easily and apply the fit the initial values, then you easily calculate the results. And second is third, in the three-dimensional model, the three-direction model. In this model, we goes to drug via vents. That's the like to example of the glucose in the drip system. Then there is by one directional nature of the cardiovascular system, and this capillary bed transport to drug carried veins to blood, the target region. Then the infusion of drug unit goes to in arterial blood, is represented by W, and then after transmission rate B, it goes to tissue, and C the veins, and lastly elimination by the liver and other body parts. Then the equations is three equations. Then the first equation for W, second is for the Y, third is for the Z. And these equations are we solve, and then easily we interpret the results for the drug diffusion. Same like for the calcium buffer model, these are the different mathematical model is known as biomathematical model. This study main object that discuss four buffer, AGTA, troponin, and converting buffer. These buffers are depend as solutions that resistance the pH in the human body. That's the maintain of the pH of the body. The BPTA primary buffer is the maintain the toxic calcium overloaded. AGTA collecting agent is the maintain the buffer equal to the pH in the living cells. And clonidine is the buffer for important the brain system. And also clonidine is the regulatory protein used to detect challenging in the calcium ion concentrations. Then this problem is see the grammatically diagrammatically here yellow dots show for the free calcium, and there is the red dot for the buffer, and these are the joining yellow and the red is the buffer calcium bond. Then they convert in the bidirectional reactions in the mechanism, a chemist in like to chemical equations. Then the C is the calcium ion, and B is the buffer, and this CB is represent the bonding of calcium buffer, and L and I are the rates. They the like to chemical reaction C plus B inter reactions is equal to CB. This is the chemical reactions. In the convert to in the mathematical equations, then we easily convert these equations. And for the changes in the C and this type, and the changes of B and changes in the CB. Here the ohm, gamma, omega are the diffusion coefficients rates for the calcium ion buffer and the bonding for the calcium and buffer bonding. Then this equation we convert again the mathematically and apply the introduction non-dimensional variables and the some substitutions. Then we reduce the in the simple partial differential equations with the boundary conditions. Easily we solve this equation, and we find the solutions of this model. Then the next is the BSP test for liver functions. It like to also the biosystem model for the like to biochemistry. This study that aims to detect the liver abnormalities. Your liver is working as the good or not. Then we test is the BSP test. The BSP is the coloring agent. The element via the liver through the injections, and then after some times there are different time period we check the some test, then the BSP concentration the decline in the blood is strong, and how to reduce in this time. If reduce is I think the 1 hour and 30 minutes, then the liver is okay. Otherwise, the liver is some problems. They the types they also the BSP test for the liver functions. This the equation is convert to equations. Then R is represent the blood and W is the represent the liver. The R is the concentration in the BSP in the blood, and the W is the concentration of the BSP in the W. And the simple is two equations. We solve these equations easily from the any mathematical technique, and the find the results. Another like to economics model, the supply and demand dynamics, and this like to price adjustment based on the supply and demand. The mathematical representations, this model is convert that dp upon dt is equal to alpha is some rate and d minus sp. P is the price or with respect to time demand, d is the demand function, and s is supply functions. Alpha is rate Then we calculate these types. Then the demand curve, law of demand. If prices is increased, then definitely demand is decrease. Then the price is increased, then demand is also increased. The demand show relation between the price at good, then the quantity of the consumers are willing to purchase. Like to second is law of supply, and third is the marketing equilibrium point. The equilibrium point will not denoted by P star, then occurs to supply equal to demands. Then at this point, the price with respect to demand and the price with respect of supply, and this cutting point is known as equilibrium point. If equilibrium point, then is good for the supply and demand chain, these types. And dynamical of this price, when the supply exceeds demand, then supplies are increased comparison to demand, then price is decreased. And when demand is exceed the supply, then demand is increased and supply is decreased, then price also increases. This is the solve of these equations, and the results also we find in another forms. The conclusion of this talk: the mathematical modeling is served as a powerful framework for the understanding and solving the real problems. We see the epidemics model, biomathematical model, and supply chain model, and also growth models. By the systematically following the modeling process, we can apply mathematical concept effectively across diverse fields like to chemistry, physics, engineering, economics, social science, and any others. Mathematics all aware the language of the universe, the Galileo, the language of written by the universe, God. This type of the mathematics is available or everywhere. Then third is with the continuous advancement in the technology, mathematical models will become even more vital, taking the complex global problems. The sustainability development and environmental preservation and the fundamental to ensuring a balanced future for the humanity. The main task, the sustainability development and the balancing of the major resource, then so air, water, and earth and energy is major resource parts. And the scientific research must be strive to achieve a harmonious coexistence between the nature and human development. And leveraging the modern science, technology, interdisciplinary collaborations is the key to addressing global challenging effectively. Without interdisciplinary is not possible because all sciences, all things are the interlinked. These are some reference. Thank. Yeah, any questions and suggestions, audience?
Dear participants, this is question and answer session. If you have any doubts, you can clarify your doubts.
Hello, good evening, sir.
Very good evening.
Sir, I wanted to ask you that if we wanted to pursue PhD in modeling, then what will be the current topic?
Yeah, the current topic the modeling is any disease you take, no problem. But currently is the control system applied to control dynamics, how to optimization problem, also the bifurcations in the PhD.
Okay, sir. Thank you so much.
Yes, welcome. Yes, any questions?
Anybody having doubts? You can post your questions in the chat box. Really, thank you so much, sir. Very wonderful session.
Thank you. And
Thank you for your valuable time. Even your Today is your resting time.
Thank you, Miss. Thank you, ma'am. Thank you.
Comedy.
Ma'am,
Conclude.
now I'm pleased to invite Ms. Vaishnavi, second BCA, to propose vote of thanks.
Good evening, everyone. It's my privilege to extend a heartfelt word of thanks to all behalf of our institutions. First and foremost, I would like to express our deepest gratitude to our esteemed address speaker uh, for the insightful and engaging on topic. Your valuable have truly enlightened us and recent learning opportunities. Special thank to you, our the best and the organizers who have worked really to make this event a success. Your dedication and the support has been instrumental in ensuring everything runs smoothly. I also extend my appreciations to all the participants for their active involvement. Your enthusiasm and the curiosity made these sessions even more meaningful. Lastly, a big thank you to our technical and logistic team for handling all the behind the scenes of work seamlessly. With this, we concluded today's sessions. Look forward to seeing you all for the upcoming events. Thank you.
Thank you, Vaishnavi, for your generous gratitude. Dear participants, we value your feedback to help us improve. We kindly request you to share your thoughts before you leave. Your feedback link has been sent to chat box. Thank
Thank you, sir.
Thank you very much. Thank you. Thank you, ma'am. Can I leave, ma'am?
Ah, yes, sir. Yes, sir.
Okay. Thank you, ma'am.
Okay. Thank you, participants. Normally, Vaishnavi. Sanjay and Salakma, thank you so much.
Thank you.
Thank you, ma'am. You know, we wind up the session.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am. Sanjay, feedback link to the other post.